So today's question was, how long would a line of 1 million pennies be? How long would the side of the square made of 1 million pennies be? How long would it take to stack 1 million pennies? And how high would a stack of 1 million pennies be? So we will go in order. So who would like to share how they solved the first part of this question of how long would a line of 1 million pennies be?
So what we did first was we measured the penny and how long it would be, and then we knew that it was a line of 1 million pennies. So then it was 2 centimeters. So 2 times 1 million would be 2 million. So a line of 1 million pennies would be 2 million centimeters.
Did anyone approach this in a different way?
So we measured our penny. It was 2 centimeters. So we used the method that we used yesterday. And then, so we did we wrote over here, 1 penny equals to 2 centimeters. So 10 pennies equals to 20 centimeters. And we kept doing that, and we got to 1 million pennies equals to 2 million centimeters. And then, so this was our final answer, and then we move on to the next one.
So now, for a question like this, because 1 million pennies is a big number, it makes sense to chunk the numbers like this group did. Now, the previous group did, they just went from 1 to 1 million right away. But this shows us that there's a pattern here. And the pattern, once you get to know the patterns, it makes life so much easier. And this is what the group showed us here, is that there's a little pattern, and it'll help us solve. So really, all you need to know is how many centimeters, how long 10 pennies are. And then from 10, you can multiply, right? So if I found out 10 pennies, how can I find out 1 million now? If I only had 10 pennies as my answer.
If you multiply 10 by 100,000?
Yeah, multiply it by 100,000. And then you get your answer. Because it's very unreasonable for me to ask you to get 1 million pennies. Because pennies don't even exist anymore. So you'd really have to go digging through lots of people's couch seats, right? Just to find pennies. But they're gone. But even if they were here, it's just too much work to do. So there's shortcuts here. I'm hoping that the shortcuts shown here, or other ways of doing it, are showing up in the next answers too. Who wants to share with us how long would the side of a square made of 1 million pennies be?
So for this, we use what we knew about the second one. The first question, it was that a line of 1 million pennies would be 2 million centimeters. So what we did with that, so we know that a square has 4 equal sides. So what we did, we took 4, so like for 4 equal sides, we took 2 million, and we did 2 million divided by 4, and we got 500,000. So that a line of pennies in a square would be 500,000 centimeters.
How many pennies would be in that line? Because here you did it with the length, right?
And if you, for that, since we know that one of them is 2 centimeters, if you just split that in half, because 2 leaves half, you get 250,000 pennies.
So if you have 1 million pennies, one side's going to have 250,000. Is there another concept that you guys know that makes it easy to remember something like this? Remember, 4 sides to a square, 1 million pennies. Hiram?
Like each side is going to be like the same.
You know every side's the same, so that's a bonus. Is there another number or another thing that you know of that has, say, a number that's similar to 1 million, and then you divide it by a certain number, like 4, and you get an answer that's kind of similar to 250,000?
100.
100. Where in money would we see, what is 100? What does it really mean in certain things?
4 quarters.
4 quarters. 1 loonie, which is $1, if you divide it by 4, that's 4 quarters. This is exactly what this question wanted you to do, is to break it into 4. So remember yesterday when I said that you don't really need to know 1 million divided by 4. If you know 100 divided by 4, something that you learned back in grade 3, something that you see every day when you go shopping with your family, then you can make that connection for a bigger number. $1 is 25 cents if you break it into 4. 1 million pennies, if you divide them by 4, is 250,000. The numbers are still the same. Okay? Who wants to attempt to answer how long would it take to stack 1 million pennies? Now the answers for this will vary depending on how good you are at stacking pennies.
Okay, so first it took us 16 seconds to stack 10 pennies. So we did 1 million, since there's 1 million pennies that we have to stack in total, and we divided by 10, and that brought us to 100,000. And then we did, since it took us 16 seconds to stack 10 pennies, we did 16 times 100,000, and then it ended up to be 1,600,000.
So why is this method a method that makes sense? Why did you time yourself, or why did this group time themselves stacking 10 pennies? Why 10? Let's go with Vishal.
It's like the pattern that you taught us yesterday.
Yeah.
It's easier to just get to a million, or like wherever you're going to. Easier to do that.
Right, and if you stack it at 10, what's another reasonable number that you could have stacked and timed yourself? 100. 100 is a great answer. Anything higher starts getting a little ridiculous. But 10 is a great number. You could have even done what? If 100's too high, 10's too low, what else could you have done? Allie? 50. In fact, when at the bank, there used to be 50 pennies in a roll. Right? So 50 is the common number. What else could you have done? We've got 10, 50, 100. What else could you have stacked if you wanted to get a different answer? 25. You guys are all using something called, are you ready? If you remember this, we talked about this last year. These are all called benchmark numbers. Okay. So a benchmark number in this situation represents 10, 25, 50, 100. Because these numbers, they're manageable. Okay? If this group right here stacked 18 pennies, then it gets hard. Okay? Not that it's not something you can't do. You could do it. This just becomes simpler. Okay? And then 1.6 million seconds, you could convert that to minutes, you can convert that to hours. Okay? And that one's a little bit more tricky, but don't worry about it. Okay? Benchmark numbers are your friends. Okay? You don't need to know how to divide 1 million, but you need to know how to work with 10, 25, 50, and 100. Once you get the handle of this, numbers become even easier for you. Okay? 10 won't always work. 25 won't always work. 50 and 100 will sometimes work. But as long as you know when to use each one, you're good. How high would a stack of 1 million pennies be? So how did we tackle this one?
So basically, when you're multiplying fractions, you want to move the decimal over how many zeros there are. So then in this case there were 6 zeros, so then we moved the decimal from here all the way over. So we got 200,000 centimeters. And then this is the place value chart of, because we started in the thousands, the tenths.
So you measured the width of it, right?
Yeah.
How thick it was, and you got 0.2.
Yeah.
So can they have applied the same pattern that we have just been doing the last day and a half with 0.2? They could have. And in fact, 0.2 is almost like saying 20, right? Because 0.2, it is equal to 0.20. So there's another benchmark, well, really a benchmark number 20. If you divide 20 by 2, it then becomes 10. So the numbers are all like manageable now. So this was a good number because 0.2. So even if he stacked 10 pennies, how high would the 10 pennies have been? If 1 penny is 0.2, 10 pennies high is how many centimeters? 2 centimeters. Because 0.2 times 10 equals 2. But there's your little benchmark here. So even if you just did 10, you can multiply it out and get your answers.